To understand the scale of this mission, look at this timeline. If you map out the 8 minutes it takes light from the sun to reach Earth, and then keep stretching that scale, you have to keep going for nearly 20 hours to hit the point where humanity's most distant radio signal currently sits. That signal belongs to Voyager 2. Right now, it's drifting roughly 143 astronomical units from home, about 13.3 billion miles out into the cold radiation of interstellar space. To get that far, NASA had to capitalize on a rare planetary alignment that occurs only once every 175 years. In 1977, that alignment gave engineers exactly one shot to launch a probe on a trajectory past all 4 outer planets. The hardware managing that journey is a relic of its time. The computer on board has less processing power than a modern musical greeting card, and the mission was originally expected to finish its work and power down in the early 1980s. Instead, it's still operating. Voyager 2 relies on radioisotope thermoelectric generators that turn the heat from decaying plutonium into electricity. As that plutonium decays, the spacecraft loses power watt by watt, surviving right now on borrowed time. On the literal brink of electrical death, this fading machine is returning measurements that the most advanced modern simulations never predicted. For 60 years, astrophysicists modeled the edge of our solar system as a soft, gradual transition, a fading of the sun's influence as it merged into the interstellar medium. When Voyager 2 reached that boundary, it recorded a sharp, violent jump in particle density. Instead of a soft gradient, it hit a compressed shock front. Thermal readings spiked to 50,000 Kelvin, a massive heat signature in a cold environment. These measurements showed that the mathematical models physicists had used for decades were structurally flawed. The edge of our solar system was far more energetic than the theory allowed. This forces a change in how we plan for deep space. Any future mission attempting to leave the solar system must now account for a violently hostile boundary rather than a quiet cosmic transition. Voyager 2 is also correcting data closer to home. When the probe swept past Uranus in 1986, it detected electron radiation belts that were significantly stronger than any planetary model predicted. With no other spacecraft sent to verify the findings, that radiation anomaly remained a major unresolved mystery in planetary science for 40 years. In 2026, researchers analyzed the flyby data alongside new solar models and realized Voyager 2 had simply been unlucky. The probe flew through a rare, intense solar windstorm that temporarily flooded Uranus's radiation belts with extra energy right as the spacecraft arrived. This means 40 years of Uranus models were based on a single statistical anomaly that was mistaken for the planet's standard environmental state. Keeping this data flowing requires NASA to make brutal compromises. As the plutonium generators fade, engineers must decide which instruments to permanently kill so the rest can stay powered. In October 2024, they made the call to permanently shut down the plasma science instrument, sacrificing one of the few remaining sensors specifically to buy more time for the others. They've also begun tapping into a secret reservoir of backup power, energy originally reserved purely as a safety buffer for the voltage regulator. It's a risky hack, using power that was never intended to run science instruments. The connection is incredibly fragile. Because of the vast distance, when a routine command accidentally tilted Voyager 2's antenna just 2 degrees away from Earth, the signal vanished entirely. It took an interstellar shout from Earth's largest transmitters to get the probe to realign. NASA now treats every day the spacecraft survives as a bonus. The mission exists in a state of constant tension between the threat of total silence and the potential for one final discovery. The decline is unavoidable. Sometime between now and the early 2030s, the decaying plutonium will finally drop below the threshold needed to run the radio transmitter. There will be no warning before the end. This 50-year conversation will simply stop mid-sentence, leaving the probe to drift in silence. Once that threshold is crossed, the mission is over. There is no way to send a technician 13 billion miles to swap a battery or refuel the generators. But the spacecraft itself will keep moving. It will continue its drift into the interstellar medium at over 15 kilometers per second, long after its electronics have frozen. Bolted to its side is the golden record, carrying human greetings, music, and a recording of a mother's heartbeat. It was designed to act as a time capsule for whatever might find it in the deep future. Voyager 2 provides a physical baseline for humanity's longevity. Scientists estimate that long after the continents on Earth have shifted into unrecognizable shapes, this 1970s machine will still be drifting through the dark, a mechanical artifact that outlives the very civilization that built it.